Good day, everyone. Today we are going to discuss determining the dependent and independent variables and finding the domain and range of a function. These are the objectives for today's lesson. Identify the independent and dependent variables. Identify the domain and range of a function expressed in words, function, rule, symbol, table of values, ordered pairs, and graph. And relate the concept of domain and range to real-life situation. Before having the definition, let us first an activity. So, activity 1, the variables. So, determine the quantities, the change, or the variables in each of the following situation. Item number 1 is done as an example. So, we have here, Rosario is making souvenirs for a friend's wedding. The number of invited people to attend the wedding determines the number of souvenirs she must make. So the variables for this situation are the number of invited people and the number of souvenirs. Let's have activity number 2. George is selling brownies online. The more brownies he sells, the more money he earns. So the variables for this situation is or are more brownies he sells and more money he earns. Situation number 3. A bakery in Cabadbaran City sells different types of bread. The more bread the customers buy, the more sacks of flour they will use. So the variables are more bread the customers buy and more sacks of flour they will use. Now let's proceed to number 4. During the school's Mathematics Month celebration, the mathematics teachers initiated different contests, categories, and bought medals for the winners. The more contest categories there were in the celebration, the more medals the teachers need to buy. So for this situation, the variables are more contest categories and more medals the teachers need to buy. So for activity number 5, Warren is going to take second quarterly exam. The number of hours he spends studying determines the score he will get in the exam. So the variables for this situation are number of hours he spends studying and the score he will get in the exam. So those are the variables for the different types of situation. In the previous activity, we have shown there the different types of variables in each different situations. Now, how do we know which variable is dependent and which variable is independent? Now, we have here the first definition of independent variable. Independent variable is a variable that will change by taking on different values. It changes independently. In a relation, independent variable controls the dependent variable, meaning independent controls the dependent. It is generally represented by the x variable or what is referred to as the x value. Now, for the dependent variable, we have here, dependent variable is a variable that is affected by the independent variable, and it changes in response to the independent variable. In our relation, dependent variable depends on the independent variable. It is generally represented by the y variable or what is referred to as the y value. In the previous activity, the two variables in a scenario are the number of hours Robert works and the amount of money Robert earns. How do we know which variable is independent and which variable is dependent? In this scenario, which must happen first before the other occurs? which variable controls the other, and which variable depends on the other. If you say Robert must work first before he earns money, then you are correct because the independent variable is the number of hours Robert works, while the dependent variable is the amount of money Robert earns. If you can see, the amount of money Robert earns is actually a function of the number of hours he works. For instance, if he earns 40 pesos for every hour he works, then he earns 200 pesos for working 5 hours. The relation can be presented using this equation. So we have here f of x is equal to 40 times x, or 40x. Now, so if you have the per hour, or the hourly rate of Robert, which is 40, and Robert works for 5 hours, you replace the variable x with 5. So 40 times 5, that's 200 pesos, and that's the amount he earns if he works for 5 hours. Now, is it possible to know how much to pay him if we do not know how many hours he worked? The answer is no. In order for him to get paid, he needs to work for a certain number of hours first. So the amount of money he earns is a function of the number of hours he works. In this scenario, the number of hours Robert works is the domain and of the function, while the amount of money he earns is the range of the function. Now, what do we mean by the domain of a function and range of a function? Let's have their definitions. The domain of a function is the set of all acceptable inputs. Generally, domain is the set of x values, or the abscissa of the ordered pairs of the function, while the range of a function is the set of resulting outputs. Generally, range is the set of y values, or the ordinate of the ordered pairs of the function. Common misconception is we can use any numbers for the inputs or domain of a function, and that is very wrong. In fact, we must inspect the function and determine any limitations on the domain because it has limitations also. So now let us first determine the domain and range of a function given sets of ordered pairs. We have here example number 1. Determine the domain and range of the function 0 and -3, 2 and 5, -1 and -1, -3 and 15, 1 and -1. So in an ordered pair and x and y, the first elements, or the x values or abscissa, are the elements of domain. And the second elements, or the y values, or the ordinate, are the range. We know that domain is the acceptable input. Hence, in this case, the domain that is arranged in an ascending order is the set of the numbers -3. You have here -3, -1, 0, 1, and 2. So, the one highlighted in red are the domain, or the x values, or the abscissa. We have here -3, -1, 0, 1, and 2. This is arranged in ascending order, but you can also write the domain as how it appears in the set of ordered pairs. Now, for the range, we have here the values that in blue. We have here -3, -1, 5, 15. So, this is also arranged in ascending order. But you need to remember that you can also write the domain or range as how it appears in the set of ordered pairs. But list down the repeating number once. If you see a repeating number in the given function, you only need to write that down once. Now let us proceed to the domain and range of a function using the mappings or diagrams. For example, number 2, we have here determine the domain and range described by the mapping below. So we are given a map. Now, the domain and range are easily recognized in the mapping. The domain is the first set of numbers in the diagram, and the range is the second set of numbers in the diagram. Therefore, our domain here is 0 and 4, and our range are 2 and -8, or -8 and 2. Now let's proceed to the domain and range of a function given the notation or equation. For example, number 3, given this function f of x is equal to 3 over x, 0 cannot be substituted for x since division by 0 is undefined. So we have here the equation f of x is equal to 3 over x. When you substitute x with 0, that is undefined because any number divided to 0, the answer is always undefined. So hence the domain is a set of all numbers except 0. So in set notation, this is the set notation for domain. For domain, x is an element of real numbers such that x is not equal to 0. Any number pwede mapuli ni x, dili lang pwede si 0. Okay, if 0 si x, then our answer is undefined. And for the range also, y is an element of all real numbers such that y is not also equal to 0. Since range is the set of all real numbers except 0. Because having 0, we will produce an impossible output. Now let's proceed to example number 4. Determine the domain and range of the function f of x is equal to 2x plus 1 over x plus 2. So the denominator x plus 2 cannot be equal to 0 since division by 0 again is undefined. So determining the value of the restriction, we are going to have this one. First, the denominator cannot be 0. So our denominator is x plus 2 is not equal to 0. Dili jud siya pwede ma-equal ni 0. Second one, we are going to apply addition property of equality on both sides of the equation. And we are going to apply additive inverse property. So 2 minus 2, that is 0. 0 minus 2, that's -2. Then we can say x must not be equal to -2. Therefore, our domain is x is an element of all real numbers such that x is not equal to -2. Because -2 will make the whole denominator become 0. So if ilisa na to si x of -2, we have here -2 plus 2, the answer is 0. Now if your denominator is 0, if you divide a number to 0, that is always undefined.
Okay, so now we are going to find the range of a function given the notation or equation f of x is equal to 2x plus 1 over x plus 2. So this is our given. Now to find the range, we need to get the inverse of the function by following the procedures. So I am going to illustrate the procedure. First, you are going to replace f of x by y. So this will become y is equal to 2x plus 1 over x plus 2. Next, you are going to interchange the values of x and y. So this will become x is equal to 2y plus 1 over y plus 2. Next step, you are going to multiply the equation by the LCM. So this is x times y plus 2 equals 2y plus 1 over y plus 2 times y plus 2. Okay. So you are going to apply next the multiplicative inverse property. So this is cancelled out. What remains is 2y plus 1 x times y plus 2. Next, you are going to apply the distributive property. So distribute, so that will become xy plus 2y, 2x rather, equals 2y plus 1. Next, you are going to combine like terms by addition and additive inverse property. So this will become xy minus 2y equals 2x negative 2x plus 1. Next, you are going to factor out y. So this will become y times x minus 2 equals negative 2x plus 1. And apply the multiplication property. So this will become y times x minus 2 times 1 over x minus 2 equals negative 2x plus 1 times 1 over x minus 2. So you are going to apply multiplicative inverse property to simplify. So this will become y is equal to negative 2x plus 1 over x minus 2. So this is now our inverse of the given function. This is what we call the inverse of the function f of x is equal to 2x plus 1 over x plus 2. By inspection, the inverse has limitations too. The denominator here, this one, x minus 2 must not be equal to 0. This restriction applies to the possible outputs or range of the original function. So, we are going to focus to the denominator of the inverse of the function. So, the denominator is x minus 2. The denominator here is x minus 2, and this should not be equal to 0. So, by addition property, this will become x plus 2 minus 2 is not equal to 0 plus 2. Cancel that out. What remains is x is not equal to positive 2. So, therefore, our range y is an element of all real numbers such that y is not equal to positive 2.
Now let's proceed to example number 5. Determine the domain and range of the function f of x is equal to 2 square root of 3x minus 5.
Now let's have example number 5. Determine the domain and range of the function f of x is equal to 2 square root of 3x minus 5. So you need to remember that the domain is the set of acceptable inputs. It seems that any value can be used, but when we look closely, note that the square root sign or the radical sign or symbol requires some limitations. we know that we cannot take the square root of a negative number. So whatever under the square root must be greater than or equal to 0. So in this case, 3x minus 5 must be greater than or equal to 0. So that is our limitations. So, by addition property, this will become 3x minus 5 plus 5 is greater than or equal to 0 plus 5. Now, let's apply additive inverse property from step 2. So, this will become 3x is greater than or equal to positive 5. Now, let's apply multiplicative inverse. This is 1 over 3 times 3x is greater than or equal to 5 times 1 over 3. So this will become x is greater than or equal to 5 over 3. So this is now our domain. Or therefore, the domain are all values of real numbers greater than or equal to 5 over 3. In set notation, that would take us to domain is that x is an element of all real numbers such that x is greater than or equal to 5 over 3. Now let's proceed to the range. How do we find the range or acceptable outputs? Again, we are going to consider the square root. So we know that this value is 3x minus 5 and it should be greater than or equal to 0. It must be positive or 0. So given the function, so we have f of x is equal to 2 times positive or 0. It could be a positive number or 0. So the range of the function f of x is equal to 2 times square root of 3x minus 5 is all real numbers greater than or equal to 0. So in set notation, that is y is an element of all real numbers such that y is greater than or equal to 0.
Now let's proceed to example number 6. Determine the domain and range of the function f of x is equal to 2x minus 1.
For example number 6, we are going to notice that there are no limitations in the domain of the given function. We can use any values for this function. Also, there is no limitation in the range. Hence, the domain and the range are the set of all real numbers. So in set notations, we can write this as x is an element of all real numbers, as well as for the range, we can write it as y is an element of all real numbers since there are no limitations. It could be all set of all real numbers.
For the next part, we are going to find the domain and range of a function described by graphs. So we have example number 7. Determine the domain and range of the given set of points plotted in the Cartesian plane below. So this is our Cartesian plane, and we are going to identify or determine the domain and range of the set of points given in this Cartesian plane.
For example number 7, we are going to determine the domain and range of the set of points plotted in the Cartesian plane. So first, we are going to enumerate the set of ordered pairs. So let's start from left, going down here. So let's begin. So the set of ordered pairs we have first, this is negative 4 and positive 3. The next one, we have negative 2 and positive 2. Next, we have here 0 and positive 1. We have here 2 and 0. Next, the last one, we have 4 and negative 1. So this is the set of ordered pairs plotted in the Cartesian plane. Next, we are going to determine the first elements because they are the x values or abscissas. Now, if we are going to determine this, it automatically sets the domain. So the first values are -4, -2, 0, 2, and +4. So we can write this as domain. We have here -4, -2, 0, 2, and +4. You can write this in ascending or descending order, or you can just write it as is. Kung unsay nakita nimo nga arrangement, pwede ra ka na isulat. Pwede pod in ascending or descending order. But you need to remember, kung kaduha ni present ang same number sa element, like nagdoble si 2, let's say 2 dire, then 2 po dire, you can write that as 1. Now let's proceed to the range. The range here are the second elements because they are the y values or ordinates. So the second elements are 3, 2, 1, 0, and -1. So we can write that as range 3, 2, 1, 0, and -1. Again, if kaduha ni appear ang number, you can write it as 1. And pwede siya in ascending or descending order, or pwede ra pod as is kung niunsa siya pag-appear sa imuhang pag-enumerate sa set of ordered pairs.
For example, number 8, determine the domain and range of a function described by the graph at the right or below. So we have here the graph. So we are going to determine the domain and range of the function described by the graph.
Okay, now let's have example number 8. So to determine the domain, visually, consider the x values or inputs taken by the graph. So looking in the x values horizontally from left to right, you can see that there are no breaks or gaps in the graph. Where it begins and where it ends, there are no breaks. Since this graph does go infinitely left and right without any gaps, the domain is the set of all real numbers. So we can write that the domain is this element of all real numbers. Now for the range, look at the y values or outputs taken by the graph. So you are going to look vertically. So from the bottom going up, you can see that there are no gaps in the graph where it begins and it ends, but there is a restriction. Since the lowest y value is -4 here, that is the lowest y value. And the graph extends infinitely upward, then we can see that the range, our range, is all real numbers such that y is greater than or equal to -4 because it goes upward.
For example, number 9, we have here, find the domain and range of a function described by the graph. Again, we are given another graph.
Now let's proceed to example number 9. We are going to determine the domain and range. Now to determine the domain visually, we are going to consider the x values or inputs by the graph. So we are going to look horizontally. As you can see, the graph breaks at 1. Here, our x value. And this is our highest x value. The graph goes infinitely to the left starting from +1. Therefore, the domain is the set of all real numbers. So we are going to write this in set notation. The domain is an element of all real numbers less than or equal to 1. Because we are going down and our 1 here is the highest x value. Now for the range, we are going to look at for the y values or outputs taken by the graph vertically going down, from up going down. So we are going to identify the highest value for y. The highest value for y here is positive 2. Highest y value. Now, since the highest y value is positive 2, the graph goes infinitely down starting from positive 2. Then the range is an element of all real numbers less than or equal to positive 2. Since it's going down, we are going to use less than. And equal to, we are using or equal to because this part here is not hollow. It is shaded. And this is also a solid line. That is why we are using or equal to.
For example number 10, we have here, again, find the domain and range of a function described by the graph. So we have here another graph that is different from the first graphs presented.
Now let's proceed to example number 10. To determine the domain visually, consider the acceptable x values or inputs taken by the graph by looking in the x values from left to right or horizontally. So as we can see, the graph breaks at negative 3, but take note of the hole at point negative 3 and 1. This means that the lowest x value is almost at negative 3. As you can see, this is the lowest x value. But we are going to exclude negative 3 because of the hole. So the graph goes infinitely to the right starting from negative 3. But since there is a hole at the point negative 3 and 1, it means that negative 3 is not included in the domain of the function described by the graph. Therefore, the domain is the set of all real numbers such that x, let me rewrite this. The domain is a set of all real numbers such that the domain is greater than negative 3. Now let's proceed to range. For the range, we are going to look for the y values or outputs vertically. As you can see, the graph has a hole at positive 1. Si kanina hole, this is in line with positive 1. Therefore, our positive 1 is the lowest y value. This means that positive 1 is the lowest y value, but it is not included because of the hole. So, the graph goes infinitely upward starting from 1. Hence, the range is the set of all real numbers such that our y is greater than positive 1.
For example number 11, we have here, find the domain and range of a function described by the graph. This is the final graph. We are going to find the domain and the range of this function.
Now let's proceed to example number 11. So let us determine first the domain by looking horizontally. As you can see, the graph breaks at negative 3 and almost at positive 2. Why almost? As you can see, there is a hole, meaning we are going to exclude positive 2 but include negative 3 because it is shaded. So, we are going to take note of the solid points. The solid points for domain are solid points for domain are negative 3, negative 3, 5, negative 5, and 2 and 0. So these are the solid points for the domain. The lowest x value is, this is our lowest x value, is -3, and the highest x value is +2. Hence, the domains of this function described by the graph is all, let's write it down in set notation, is the element of all real numbers such that x is greater than or equal to -3 but less than +2, because our domain focuses on the line presented in the graph, or the graph, including this -3, excluding +2. Now let's proceed to range. Now let me erase this one. For the range, we are going to inspect the graph vertically. As you can see, the point here is shaded and it is in line with -5. Therefore, our -5 is the lowest y value, while the highest y value is the one that passes here, which is 4. So this is our highest y value. Now, since the lowest y value is -5 and the highest y value is 4, then our range, that y is an element of all real numbers such that y is greater than or equal to -5 but less than or equal to 4. Y or equal to, because this is a solid line. So that is our domain and range for example number 11.
Now, in finding the domain and range, you need to remember that to find the domain and range of a function described by its graph, look in the x direction, or the horizontal part, from left to right for the domain, and y direction, or the vertical part, upward and downward for the range. Then look for any breaks or gaps in the graph, where it begins and where it ends. Use this data to list your domain and range. Now let's have an activity. For this activity, we are going to call this "To Whom I Depend On." For the directions, we have here, given each situation below, determine each variable in italicized form, whether independent or dependent, and determine if the said variable controls or depends on the other. Item number 1 was done as an example, but we are going to do item number 1 to 5. So item number 1, Doris was looking for a job. She noticed that the higher paying job requires higher education. So higher education is the blank variable because it blank the variable higher paying job. So what do you think is the answer? Higher education is the independent variable because it controls the variable higher paying job. Now let's proceed to number 2. Roberto buys 2 kilos of dressed chicken at the market. How much will he pay if the chicken costs 155 pesos per kilo? So the cost of the chicken is the blank variable because it blanked the number of kilograms of chicken. So what do you think is the answer? The cost of the chicken is the dependent variable because it depends on the number of kilograms of chicken. So, ang presyo or ang bayaran is dependent siya Kay nagdepende man siya kung pila ka kilo ang chicken. Now let's proceed to number 3. Paul planned to tile his floor. He measures the length and the width of his floor to calculate the area. The area of the floor is the blank variable because it blank the length and the width of the floor. So, the area of the floor is the dependent variable because it depends on the length and the width of the floor. For number 4, we have here, Jana auditioned in the Pinoy Got Talent competition. Her performances got a vote of 4 yeses from the judges. So Jana's performances are the blank variable because it blank the judges' vote. So Jana's performances are the independent variable because it controls the judges' vote. For item number 5, we have here, Eric's math grade in the first quarter was 98%. He had completed all 10 requirements. The number of requirements completed is the blank variable because it blanked the math grade. So, for our answer for this one, we have here, the number of requirements completed is the independent variable because it controls the math grade. For activity number 2, this is basically the same with activity number 1. It's just that you are going to answer this on your own and you may pause the video so you can read and understand each situation. So this is for number 1. Number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, and number 10. For activity number 3, you are going to determine the domain and range of the following items. So, the items will be shown here are somewhat alike with the examples that we discussed earlier. So, this is for number 1, number 2, number 3, number 4, number 5, number 6, number 7, and number 8. And we have here numbers 9 and 10. So you are just going to determine the domain and range of each of the following items. So that's all for today. I hope you have learned something. See you on our next meeting.